All right, this lesson is factoring simple trinomials. So what we want to be able to do by the end of this lesson is be able to write a simple trinomial. Now, what do we mean by a simple trinomial? A simple trinomial would be something like x squared plus bx plus c, where b and c are both numbers. So ordinarily we would have an a out here, but in simple trinomials, the a is just 1, so we don't often write it. So we want to take something that looks like that, a simple trinomial, and write it as a product of two binomials. So product means these two things are multiplied together, and a binomial might look like something like, I don't know, x plus p, x plus q, where p and q are both letters. Okay? So let's just put this in the context of what we've been doing up until now. We have been doing some expanding, and we know in expanding, we see something like this, 3x times 2x minus 4. We know to take the 3x, multiply it by the 2x, to get 6x squared. And we also take the 3x and we multiply it by the negative 4 to get negative 12x. So what we have done there is we have taken something using the, that is in what we would call a factored form, right, where it's written as a product, 3x times 2x minus 1, and we write it in what has been what we might call standard form, where it's like a polynomial with a bunch of terms connected by addition and subtraction. So in expanding, we're going from factored form to standard form. In factoring, we are doing the opposite, right? We start with something in standard form, and we want to put it into factored form. So we want to write this as things that are multiplied by each other. And we did this in our last lesson. We looked at what was common between our 2x squared and our negative 8x, and we would say, okay, well, both are divisible by 2, so 2 is common. There's an x there, an x squared and an x, so we can factor out the lowest power of x that we see. And then we think about what needs to go in the brackets here. We need an x, and we need a minus 4. So this was common factoring or just the distributive property. We want to be able to do the same kind of thing, go from factored to standard form or from standard back to factored form for things that look like this. So we've already talked about expanding binomials. And when we did expanding binomials, we talked about the FOIL rule. And we said, okay, this is right now in factored form. We want to go from we sort of multiplied our first two terms, x times x, got us an x squared. Then we did our last two terms, x times 3, got us 3x. Then 2 times x, our two inside terms, got us a 2x. And then our last two terms, 2 times 3, gave us a 6. And then we could always take those two middle terms, the 2x and the 3x, which are like terms, and we could add them together to get our trinomial. Okay. To do the opposite, we want to take a trinomial like we have over here on the left, and we want to be able to write it as something that looks like this times this. Now, how are we going to do this? Well, let's look at what we did when we were doing the expanding and kind of work backwards. So when we did the expanding, the first thing we did was we multiplied our first two terms, okay? This x and this x to get the x squared. If we look at what's going on over here in our trinomial, we want to end up with an x squared, right? And this x squared has to come from our first two terms. So we know right away that in order to get that x squared, we're going to need an x here and an x here. All right, and what else can we see in our expanding our binomials? Well, if we look at this term over here, this came from multiplying our two last terms together. Our 2 and our 3 multiplied to give us a 6. So in our trinomial over here, we know that this term right here is going to come from multiplying the two last terms. So our last two terms have to multiply to 8. I'll say mult 2, 8. Okay, so we now can start trying to guess what these last two numbers are going to be. They could be something like, well, let's see, what numbers multiply to 8? They could be something like positive 1 and positive 8. But it could also be negative 1 and negative 8. It could be positive 2 and positive 4. They multiply to positive 8. Negative 2 and negative 4. Those multiply to positive 8. So all of those are possible numbers, pairs of numbers that can go in there for those last two terms. How do we know which ones are the correct ones to put in there? Well, this is where we look at what's going on in our middle term here. This middle term came about from adding our outside term and our inside term. So these two terms together got added together to give us this 5. Now, where did these two terms come from? Well, the 3x comes from our outside times our first one, right? And our 2x comes from the 2 times x, so the two insides. So the pair of numbers that we want over here are going to be the pair of numbers that are going to add together to give us our inside term. So they have to add up to give us this 6x. So of these, 4 possibilities here, only 2 of them, positive 2 and positive 4, add to 6, positive 6. So those are the numbers that we want in here. We want to put in a positive 2 and a positive 4 in there. And there we've written it in factored form, x plus 2 times x plus 4. Now we can always confirm that this is actually the right answer by doing our FOIL, or expanding this. X times x gives us x squared, x times 4 gives us 4x, 2 times x gives us 2x, 2 times 4 gives us the 8, and then we collect those like terms in the middle, and that's what we wanted to end up with. Okay? So let's review how we actually factored this trinomial here. Okay? X squared plus 6x plus 8. We started by knowing that we wanted to have two binomials multiplied by each other. Then we looked at this and said, okay, our first term in each bracket has to be x in order to get the x squared in our first term. Then we tried to find two numbers that multiplied to give us our last number. They had to multiply to give us the 8, and they had to add together to give us the middle number. So in this case, they had to add to 6. And our two numbers were positive 2 and positive 4. And I should say that this is positive 8 and this is positive 6, because those signs are important. So those numbers, positive 2 and positive 4, become the last two numbers in each of our brackets here, plus 2 and plus 4. All right, and this is how we factor trinomials. So let's look at a few more examples here just to make sure we've got it down here. X squared plus 3x plus 2. Okay, we know that we're going to need two sets of brackets. Okay, we know that we've got x squared first, so it's going to start with an x, and it's going to start with an x. Now, we need to find two numbers that are going to multiply to our last number, which is positive 2, and add up to our middle number, which is positive 3. So we can start thinking of what are possible numbers that are going to multiply to positive 2. And there aren't very many possibilities here. We can have positive 1 and positive 2. 1 times 2 gives us 2. We could have negative 1 and negative 2, though that's going to give us positive 2 as well. Which is the pair that we want? Well, we want the pair that when we add them together, they give us positive 3. So that's going to be this pair right here. So positive 1 and positive 2. So in our factored form, we have x plus 1 times x plus 2. And it doesn't matter which order we put them in. We could have written that as x plus 2 times x plus 1. All right, let's look at our next one. X squared minus 9x plus 20. Again, I want to factor this as two binomials. my first terms are going to be x and x because they will multiply to give us the x squared. We need to find two numbers that are going to multiply to positive 20, our last number, and add up to negative 9, which is our middle number. And if you get stumped on these, just start listing possibilities, right? What multiplies to positive 20? Plus 1 and plus 20. Negative 1 and negative 20, because two negatives give us a positive. What else? A positive 2 and positive 10. Negative 2 and negative 10. What else multiplies to give us 20? Positive 4, positive 5, negative 4, and negative 5. And from this list of possibilities, we want to keep going until we find ones that add up to negative 9. So, and they, of course, are the last ones that I picked here. Negative 4 plus negative 5 is our negative 9. So we're going to put in the brackets negative 4, negative 5. So our factored form, x minus 4, x minus 5. One more here. Find two numbers. Oh, we got y squared plus 6y minus 27. Again, our first step is going to be give ourselves our brackets for our binomials. Now, instead of x, we want y here and y here because y times y is going to give us y squared. We want two numbers that multiply to negative 27 and add to positive 6. Now, this is where the signs become important, because if we want numbers that multiply to negative 27, one of them has to be positive and one of them has to be negative. So we can start thinking of things like negative 1, positive 27. That certainly doesn't add to positive 6. Positive 1 to negative 27. That's not going to work either. 27, I think there's something around 3 and 9. So I could either have negative 9 and positive, sorry, negative 3 and positive 9, or positive 3 and negative 9. Which one adds up to positive 6? Negative 3 and positive 9. So y minus 3, y plus 9. All right, so if you're following along on the sheet, there's a bunch here for you to try. So you might want to pause the video, try these ones here, and then start the video again and check your answers, because I'll go through here and do them. Okay. All right, let's take a look. We know how to start this, x and x. We're looking for two numbers that multiply to negative 18, add to positive 3. I think those numbers are going to be a 6 and a 3. 6 times 3 is 18, but I need one of them negative. I'm going to make a negative 6, or I could have a positive 6 and negative 3. Those are our two options there. Which one gives us the positive 3? It's this one right here. So I'm going to have x plus 6, x minus 3. Our next one here, x squared minus 4x minus 32. Again, x and x. I need two numbers that multiply to negative 32 and add up to negative 4. So 32, let's see, there could be 2 and 16, negative 2 and 16. But even if I change the signs, like make it positive 2 and negative 16, that's not going to work. I think the numbers that we want are 8 and 4. So let's see. Positive 8 and negative 4 is another possibility. Which one adds to give us the negative 4? Those two right there. So it's going to be x minus 8, x plus 4. And remember, the order doesn't matter. It could just as easily have been x plus 4 and x minus 8. All right. A few more down here. Let's see. Here we're going to have y and y. What are our numbers going to be here? Our numbers are going to be, I think they're going to be negative 5 and positive 4. Negative 5 and positive 4 multiply to give us negative 20, and they add to give us negative 1. So minus 5 and plus 4. Let's see, this one looks a little bit trickier. I know I'm going to have x and x. Oh, that's a y, not an x. X and x. What are my two numbers going to be here? They have to multiply to 72, positive 72, and they have to add to negative 17. All right, our numbers are going to be negative 8 and negative 9. 8 times 9 is 72. Negative 8 plus 9, negative 8 plus negative 9 is negative 17. So x minus 8, x minus 9. Our last one here, y minus 10y minus 24, a y and a y. 24 is kind of tricky here. Obviously, we want things that multiply to negative 24 and add to negative 10. What can we have here? We could have 12 and 2. One of them has to be negative, so negative 12 and 2, or positive 12 and negative 2. Do either of those add to negative 10? Yes, the first ones add to negative 10. So our factors here are going to be y minus 12 and y plus 2. All right, and that's factoring.